Hello, this is Mrs. Boots, and we're going to do the transformation practice problems. We're going to work on the first 12 problems in this video, and then we will do the rest of them in other videos to come. So the first thing we have to do, given the equation, is identify what the transformation is. So as I look at this, I notice I have my x squared, so that tells me it is a quadratic, which means my shape is the U shape. This minus 1 is a transformation. So if I put a minus 1 at the end, is that moving it left, right, up, or down? The answer is it's an up-down, and because it's negative, it's going to move it down. So we're going to go down 1. So now let's put together a graph that's a little bit more precise than just that little scribble we put down there. So I'm moving down 1. That's where my quadratic's going to start. And then I'm going to sketch in a basic quadratic function. Now your sketch doesn't have to be really big because I didn't give you a lot of room right there on the paper, but if you're particular, you can go get a piece of graph paper and do your sketch on the graph paper. Alright? The next piece we're going to do is our domain and range. So for our domain, remember, we're going to go where? We're going to go, well, this always goes from negative infinity to positive infinity for a quadratic. My range, however, now starts at negative 1. So I'm going to go from negative 1 up to infinity. Remember, the negative 1 gets a square bracket because it is included in the range of the function. Number two, what kind of function is this? Well, these beautiful little bars right here tell me it's an absolute value. And that means it is a V-shaped curve. And now let's look and see what do these two numbers mean. Well, the negative 1 on the inside moves it to the right. So I'm moving it to the right 1. And the 2 on the outside is going to be a stretch. Remember, the stretch makes it tall and thin, or tall and skinny. Alright, so now let's actually go in and draw our curve, or sketch our curve. So we're going to the right 1. That's where my V is going to start. And instead of going over 1, up 1, it's going to go over 1 and up 2. So my absolute value shape is a lot thinner than it would be normally. Okay? Let's go ahead and do our domain and range for our absolute value. Domain's super easy. Domain goes from negative infinity to positive infinity. And the range starts where? Look at the y values. Don't tell me it starts at positive 1. It starts at 0 and goes to positive infinity. Alright, number three, what kind of function is it? Well, I've got a radical, so it means it's a square root. There's no little number out here, it's just the plain old radical. I only have one transformation, it's inside with the x. The stuff on the inside is either going to move it to the left or the right. Remember, there's an opposite sign. It's going to move it to the right if it's negative, left if it's positive. Let's go ahead and draw that on a graph. So we're going right 2, 1, 2. That's my starting point. Remember, the square root function is going to go over 1 and up 1. And then over 4 and up 2, which is almost off my graph. Okay, so that's my square root function. It goes up and to the right. And now let's do our domain. Where does our domain start? Well, it starts at the x value for that very beginning of the curve, which is at a positive 2. The 2 is included, and it goes to positive infinity. And then the range also starts at that starting point, but we're looking at the y value now. And the y is at 0, going to positive infinity. Alright, number 4. Number 4 is what kind? Well, I noticed we have this little 3 in the exponent. That makes it a cubic. We've got to remember what the cubic looks like. Okay? Now transformations. The only thing I see transforming it is that 3 being added to the end. If it's being added to the end, it goes up. So we're going to move up 3. So now let's go in and draw it on our graph. So I'm going to take my function and move it up 1, 2, 3. That's where my beginning dot's going to happen. And now I'm drawing that curve. So remember, it's over 1, up 1, over 1, down 1. So we go up to the right, down to the left. Okay, that's my cubic. And now let's look at domain and range. Domain and range are easy for the cubics. Remember, we got arrows. They're going up and to the right and up and to the left. So it doesn't matter where we transform it, it's always going to be negative infinity to positive infinity. Number 5. What kind of function is number 5? Number 5 has the x in the bottom. That makes it a rational function. Remember, rational is fractional, so anytime x is in the denominator, it's going to be rational. That 6 is the only transformation. Now 6 is being added, which is really cool, but it's not outside the fraction. It's down there with the x. So that means it's going left, 6. So let's come over and draw a little graph. So I'm going to go left 6. So I've got 1, 2, 3, 4, 5, and I should have drawn my line a little bit longer. 6. There we go. Okay, left 6. That is where my rational starts. Remember, the rational was kind of weird because it basically didn't touch. So we're just going to draw a little dashed line right through there. And the curve is the cool part. Remember, the curve is up and above on the right and down below on the left, because the rational has 2 asymptotes, one horizontal and one vertical. Okay, so now let's look at our domain and range. So our domain is going to go from negative infinity all the way to that negative 6. We do not include the negative 6 because it is an asymptote, but we pick up on the other side and go to positive infinity. The range goes from negative infinity up to the x-axis, which is a 0. We're going to pick up on the other side and go to positive infinity. Alright, number 6. Number 6, I have absolute value bars. Okay, so I know it's an absolute value function, and I have 2 transformations. The one on the inside is my left and right. I have to do the opposite of the sign, so it's going to go right 5. And the one on the outside is my up and down. It's negative, so we're going to go down. Let's go ahead and draw the graph. Okay, so we're going down 2 and to the right 5. 1, 2, 3, 4, 5. That is my starting point. Down 2 and right 5. Okay, so once we go down 2 and right 5, now we're doing an absolute value. So that's over 1, up 1 on either side, and we get our V shape. Now let's look at our domain. Domain for the absolute value doesn't change. It's always going to be from negative infinity to positive infinity. My range, where did my range start? The bottom is now at negative 2, and it's going to go up to positive infinity. Alright, number 7. What kind of graph is number 7? Well, x is in the denominator, so that makes it fractional. Fractional is rational. Okay, so that means it's got two pieces. I only see one transformation though. That's the -5 and it's outside the fraction. So we're going to go down 5. So we have 1, 2, 3, 4, 5. Okay, remember that's an asymptote right there. Where's the other asymptote? Yeah, it's right along that axis. Okay, so now let's do our graph. And our graph is above and on the right, below on the left. If it were negative or reflected, then I would change that. Okay, let's do our domain and range. So my domain goes from -infinity all the way up to the asymptote. The asymptote's at 0. So I go to 0, go around my 0, and go to +infinity. My range, I go up from the bottom, so I'm at -infinity. Coming up from the bottom, I hit the asymptote. That was at -5. Go around the -5, come up to +infinity. Number 8. Number 8, what kind of function is this? Has a radical with it. It's a square root. There's no little 3 in front. So square roots start and go up and to the right. Okay. So where does it start? I have this number out front. What does that do? It does not move it up, down, left, or right. That is a stretch. It's going to make it super thin. Alright, but there's no up, down, left, right, so it's still starting at 0, 0. Only now instead of 1, 1, I go 1, 3. Okay, so it's going to get super big, super fast, if I can draw it in and actually hit my dots. Just like that. So now let's do our domain and range. Our domain starts at 0, goes to infinity, and the range still starts at 0 and goes to infinity. So notice that the stretch did not affect the domain and range. It's only the left and right movement that affect the domain and range and whether or not we reflect it. Number 9. Number 9, what kind of function is it? Well, it tells you. It's a log. Log looks similar to a square root, only it keeps going to -infinity. Let's do our transformations first. We have this beautiful -3 right here. That -3 is on the inside with the x. Inside with the x means it's a left-right. In this case, it's a right. Negative goes to the right. So I'm going to write 1, 2, 3. Remember, for log, just like with rationals, that is an asymptote. Okay, so that is actually not part of my curve, but it's one of the pieces. That's the piece that I cannot touch. Okay, so I'm going to go one more past it, and that's my log function. Comes over and comes down. Now let's go in and do our domain and range. My domain starts at that asymptote, but does not include it. My range is going to go all the way from the bottom all the way to the top. So it is a -infinity to +infinity. Alright, number 10. Number 10, I got these beautiful vertical bars. Remember, that's an absolute value. Absolute value has a V shape. And now we've got some transformations. I have a negative out front. That's going to reflect it across the x-axis. So that's going to turn it upside down. I got that 2 on the inside that's being subtracted. So that's going to move it to the right 2. So I go to the right 2. And I know I'm going to be pointing down. So instead of going up 1 and over 1, I'm going down. Okay, and that's my absolute value. Alright, so now let's look at our domain. The cool part is your domain really didn't change. It still goes to -infinity, +infinity. But the range now starts at the bottom, -infinity. And it's going to come all the way up to that point of our absolute value, which is at 0. And it is included. So remember, if we flip it upside down, we're going to have negative infinities instead of positive infinities. And the negative infinities are always going to come first. Number 11. Okay, number 11, x is in the exponent. X is in the exponent, it's an exponential, so it's going to go up and to the right or down and to the left, depending on if it's a growth or a decay. Now this one has a 3, so I know it's a growth. I know it's going to go up. Okay, so let's look at our transformations. Inside the exponent, I also have a +1. Anything inside with the x is a left-right. We do the opposite of the sign, so we're going to go left 1. On the outside, we have a +4, so we're going to go up 4. So I'm going to go up 4 on my graph and left 1. That's kind of my starting point, sort of. Okay, so remember, exponentials have an asymptote. That's actually where my asymptote lives. Now I would actually go up 1 more from that asymptote, and my curve is going to go through that point. Okay? So now let's look at my domain and range. Domain, easy part, negative infinity, positive infinity. All the way left, all the way to the right. The range, however, starts where that asymptote is. It's at 4. We do not include that 4. And it's going to go to positive infinity. Last one on this particular video is what kind of function is number 12? Well, I see that square. Square means quadratic. Means I know it's a U shape. The 6 out front, that's going to be a stretch, right? We're going to get tall and skinny. 9's on the inside with the X. Inside has to do the opposite. So we know it's going left or right. This one's going to go left 9. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. That's our starting point. Okay? Now, normally you would go up 1 over 1. But now we got to go over 1 and up 6. So my U shape just got really, really tall and skinny. Okay, let's look at our domain and range. Domain did not change. Still negative infinity, positive infinity. It doesn't get very wide very fast, but it still is going to get wider. My range starts at that point down at the bottom in the ditch of my quadratic, which is a 0. It's included, so I have to do a bracket, and it's going to go all the way to positive infinity. And this concludes the first 12 of the practice problems. We'll do another video for the next section. Welcome back. This is Mrs. Boots. We're going to do the second part of our transformation practices. Now, the first thing we have to do is go from words, description, into an equation. So number 13, they use this word radical. Remember, a radical is a fancy word for a square root, right? So I know I'm going to have a square root of x. Okay? Now what do I do with the 2/5? Well, the 2/5, it says, is a vertical compression. So that means the 2/5 is going to go out front. That is my simplest equation right there. Okay? Number 14 is a cubic. Cubic is what? X cubed. So I'm going to have something x cubed. Alright? They tell us it's reflected over the x-axis. So I know there's a negative out front. And it's shifted down 2. So it's -2 at the end. Now you could have written that squished together a little bit more because we don't have anything inside with the x. But that's okay. It's fine where it is. Number 15, rational. Rational is 1 over x, but this has a stretch by 8. So it becomes 8 over the x. Now, am I adding or subtracting anything? No. We do not have any add or subtract on this one. Quadratic, number 16. Quadratic is an x squared. So I'm going to have an x and I'm going to have a square. I know that. Now it's moved left 8. So remember, if I move it left 8 it means I have to add 8 on the inside, and then I have a vertical compression of 0.45. Stretch and compress goes out front, so I have my 0.45 out front. Okay, let's look at number 17, absolute value. Absolute value is the vertical bars. We have an X, always have an X, reflected over the X-axis. So there's a negative out front. Translated down 3, so a minus 3 at the end. Alright, number 18, square root, square root. Gotta have a square root, gotta have an X. Now what are we doing? Vertical compression of 3/4. So I got 3/4 in front, and they're moving it right 6. So that means I subtract 6, but do I do it inside or outside? We do it inside. Remember, the left right has to be inside with the X. Okay, exponential. Exponential is something to the X. And they didn't tell us, so we're just going to use a 2. Okay, so I'm going to have 2 to what power? Well, there's going to be an X because it's an exponential. And then they tell us stretch of 8. Wow, how do we do that? Okay, so let's put the 2 in parentheses so we can put the 8 out front to stretch it. And then we're translating it up 2, so I've got to add 2 at the end. Kind of confusing. Not really. 2 to the X is my original equation. Now let's do our cubic, number 20. Cubic is what? X cubed. Okay? I have an X and I have it cubed. We know it's moved left 1. That 1 has to go on the inside, and because it's left, inside is opposite. Then I move it up 9, so I add 9 to the outside. Alright? Now let's look at the last one. 21 is a log. Okay? Well, log is easy, right? Because you just write the word log. It's reflected, so I've got to put a negative out front, and then it's translated down 3. Well, does that 3 go inside with the X? No. It goes outside. So I'm going to close the parentheses to indicate that that log is just for the X, and then move it down 3 at the end. Numbers 23 through 28 are the ones that everybody gets upset over, but they're actually the easiest ones in the whole practice. They've got little stars beside them because they require a little bit of extra thought. Okay, so when I look at these, I notice it gives me a starting point. That's the tip of the absolute value, the bottom of my quadratic curve, the center of my cubic, the asymptotes, crosshairs for my rational. That's where it's at. Okay, the X value, remember, is going to go inside, and the Y value goes outside. So for my absolute value function, if -3 is the X, it's going to go inside and change signs, and the 1 goes outside and keeps the sign. Let's do the next one, number 24. So it's a quadratic, so I know it's x squared. What's inside with the x? Well, it's a 5, but I have to change signs. Okay, the 6 is outside. Super easy. Okay, cube root. Ooh, okay. So remember, that's a root with a little 3 on the outside. What goes inside with the x? The 2, but we changed the sign. Outside is the y value. That's a 4. Let's look at number 26. Rational. Rational is the 1 over x. Okay? Well, there's nothing going on with the x. It's a 0. So that's okay. That just means I leave it alone. Now we're going to take that 4 and add it to the end. If that 0 had been a number other than 0, I would have put it down in the denominator. So I would have had x plus another number or x minus another number. Okay? Cubic. Okay, so I've got something cubed. Alright? So my 2 is the x. It goes inside with x. I have to change the sign. Zeros outside, so we just don't even write it. Number 28 is the problem that stumps most of my students. And I think it's funny because it's not a hard problem. It's super easy. And they overthink it. Okay, it's a linear. Okay, so this is your good old y equals mx plus b. But everybody goes crazy. My slope is a half. Where does the slope go? Yeah, right in front of the x. So I'm going to have 1/2 x. And then my b is positive 8. And every single student, well, 98% of them miss that problem, which is very entertaining because it's an Algebra 1 problem. Super easy.